हेलो स्टूडेंट्स, आज हम गॉस लॉ पढ़ेंगे। आज के इस वीडियो में हम गॉस लॉ डिस्कस करेंगे। तो गॉस लॉ को स्टार्ट करने से पहले हमें इलेक्ट्रिक फ्लक्स के बारे में समझना बहुत जरूरी है। वी मस्ट हैव अ बेटर अंडरस्टैंडिंग ऑफ इलेक्ट्रिक फ्लक्स, देन ओनली वी कैन अंडरस्टैंड गॉस लॉ बेटर। So though we have discussed all those things in the previous video, but still once I recall the concept of electric flux. Suppose there is an open surface and an electric field E passes through it, and let the area vector of this surface is toward this direction, perpendicular to the surface, and the angle is theta. Then the flux of this electric field through this surface is defined as d phi is equals to E dot dA. So the small flux, differential flux d phi through this small surface dA is E dot dA. So simply it is the dot product of two electric field and area vector. If it is a bigger area and electric field is non-uniform varying, then we will perform the integral over all area to find the net flux. Okay, so now starting with the Gauss law. First we will write the statement. According to this law, the flux of electric field through a closed surface is always equals to 1 by epsilon naught times when 1 by epsilon naught times the total charge enclosed inside it. So according to this law, the flux of electric field through a closed surface is always equals to 1 by epsilon naught times the total charge enclosed inside it. For example, suppose this is my closed surface and there is a charge small q inside it. So obviously it will have its own electric field, and that electric field will have some flux associated with this closed area. But this time we need not to be bothered about finding E dot dA and perform the integral over all surface. Once the surface is closed, we can apply the Gauss law and directly write that the flux through it must be equals to q by epsilon. Just directly from the Gauss law. So it is a very easier method to find the flux if the surface is closed. Now we will prove this, how this is valid. We will check its validity. So proof. Suppose we have a random shape closed surface. There is no fixed geometry. I'm not taking any fixed geometry, a random closed surface, and there is a charge q inside it. So since we can say this surface is irregular, so the distance of different point on this surface will be different from this point charge, and hence the electric field will also different on the surface of this closed surface. So we have to first choose a small surface. First of all, we will choose a small surface such that over which the electric field could be assumed constant. Means we can assume कि at least at this area electric field is not varying. And let this distance is r. From this point charge, the distance of this point is r, and let the area vector points toward this direction dA, and this angle is theta. This is my situation. I assumed a small surface. I will try to find the flux through this small surface, and then will integrate over the total surface, entire surface, to get the total flux, and we'll see that whether it comes q by epsilon naught or not. So according to the definition, if d phi is the flux associated through this small area dA, then first of all we can write कि d phi must be equals to E dot dA, that is E into dA into cos theta. We can write like this. So now we will integrate it over the entire surface to get the total flux. So total flux phi must be the integral of d phi. So over a closed surface, this symbol indicates that the integral is performed over a closed surface. So do it. E into dA into cos theta. Right? Now from the Coulomb's law we can write E. The electric field intensity from a point charge q at a distance r, we can write q by 4 pi epsilon naught r square. Therefore q by 4 pi epsilon naught r square dA cos theta. So that is phi is equals to, taking q by 4 pi epsilon naught outside, q by 4 pi epsilon naught is a constant term, so can be taken outside from the integration, and dA cos theta by r square is inside. Now there is one thing कि there is a concept of solid angle कि like a line can subtend a plane angle, a surface can subtend a solid angle at a point. I show you here. If there is a surface and there is a point, then this surface can subtend. Suppose the electric field is in this direction and dA is in this direction. Then the solid angle subtended by this surface is, suppose it is d omega. Then it is something like defined like d omega is equals to the component of area vector along the electric field, that is dA cos theta by the square of distance from this point to this surface. So dA cos theta by r square is the small solid angle subtended by this surface. So it can be written as q by 4 pi epsilon naught into integral of d omega, and for a closed surface there is a concept, for a closed surface the total solid angle subtended by the surface to any point inside it is always 4 pi, So since this is a closed surface and the point is inside surface, so the total solid angle subtended by this closed surface will be 4 pi. Then it is q by 4 pi epsilon naught into 4 pi. 4 pi cancel, and here phi is equals to q by epsilon naught. So this is proved. So finally we can write the statement, mathematical statement. Mathematical statement of Gauss law phi is equals to closed surface integral of E dot dA is equals to q inside by epsilon naught. So this is the mathematical statement of Gauss, mathematical form. So we saw the statement of Gauss law, we saw its proof, and now its mathematical statement. Some more points we can note about Gauss law. First, one important point about the Gauss law, it is always valid for a closed surface. It is always valid for a closed surface. Second, it is independent of the shape and size of the surface. So it is independent of the shape and size of the surface, whether it is cylindrical, conical, spherical, whatever, it is irrelevant. For example, suppose there is a spherical body and charge q inside it, another conical surface, solid cone, and charge q inside it. One is the cylinder and one is suppose a cube. So even there is different shape, but in all these cases the flux will be same, q by epsilon 0, q by epsilon naught, q by epsilon naught and q by epsilon. So these are the some important points. Now I hope ki you must be understanding the Gauss law. It is very simple, not much difficult. Just its application is very wide. So now we will do some numericals. One numerical first we will do. Question number 1 is, suppose a closed surface is given and a charge q1, a charge q2 and a charge q3 outside it. So what will be the flux through this surface? What will be the flux of electric field through this closed surface? So my answer will be Gauss law. Since the surface is closed, I can apply Gauss law. So phi is equals to q inside by epsilon naught, that is 0, because there is no charge inside the surface. So you can also see, this is an also important point, that the charge outside surface, closed surface, do not affect. Why? Because the flux of electric field will enter this surface as well as exit also. As the surface is closed, so once it is entering, it has to exit also. So at the time of entering, it will has negative flux, and at the time of exiting, it will have positive flux. So the net flux will be 0. So outer charge doesn't affect. And also you can note a point ki entering field to the surface has negative flux, and exiting field has positive flux. So if the charge is outside, it has to enter as well as to exit. So at the time of entering, it will have negative. At the time of exiting, it will have positive flux. And so negative and positive cancel out. Now, next, suppose I take two charges like this and enclosed in a surface S1, plus 2 microcoulomb, minus 2 microcoulomb. I take some more charges, minus 3 microcoulomb and minus 5 microcoulomb, and cover it, enclose it under a surface S2, and also take a surface, bigger surface, which enclose all these charges, and let the surface is S3. So now the question is ki what will be the flux of electric field through all three surfaces S1, S2 and S3. So first of all, we start with surface 1. Now let if phi1 is the flux through surface S1, then it is from the Gauss law, Q inside by epsilon naught. So total charge inside, it is plus 2 microcoulomb and minus 2 microcoulomb, plus 2 mu c minus 2 mu c by epsilon 0, that is 0. Now let K phi 2 is the flux through second surface. So since the surface is closed, we will apply Gauss law and we will count the total charge inside it. So how much it is? Minus 3 minus 5 plus 2. Minus 3 mu c minus 5 mu c and plus 2 mu c by epsilon naught, that is minus 8 plus 2 minus 6 mu c by epsilon. And in the last, let Q phi 3 is the flux through this last surface. Then total charge is how much? Plus 2 minus 2 0, minus 3 minus 5 minus 8. Minus 3 mu c minus 5 mu c by epsilon 0, that is minus 8 mu c epsilon 0. So this is the flux. Now in this video, up to this, and next video we will deal some more numericals, some more variant of the numerical based upon Gauss law. We'll do in next video. So for this video, up to this only. Thank you very much.